That's
It's
good.
turning on and off?
No, that was me. That was an
Okay.
accident.
Alright, it's working now?
Yeah.
Alright, cool. So we're gonna talk about Einstein's equation. Basically, Einstein just got one thing wrong. He tried to look at conservation of energy and stuff, how energy is transformed and all these things, right? Except that he wasn't thinking about one thing. Right? He wasn't thinking about the mind as a form of energy. This is like culture up here. It keeps on growing. Like this tree over here, it just keeps on growing. Alright? And it's based in the physical world, like the world and the energy that we see in the environment, right? But this is a different type of energy, right? But there's actually a relationship between these two entities, right? So there's actually a very interesting, complex relationship between mental energy, right, and physical energy. So whenever anybody exerts a piece of mental energy, look, I used this example earlier and it made sense. Say we got an apple. We got two humans. All right? One of them's Einstein, and the other one is, a guy that's really lazy. Lazy guy. Doesn't like to do anything, right? So we have this apple. It's got 10 units of energy, right? In it, theoretically, according to like the physical law. Does it stop?
No.
Oh, I heard a ding. Okay. 10 units of energy. Now, theoretically, this type of apple could be consumed by Einstein and by this lazy guy. Except Einstein thinks of this whole Mc squared equation here. Because he's been working for 10 years on it, right? And now that this apple is just inputted into the system, all of a sudden, he used that tiny bit of energy from the apple to come up with this whole frickin' equation, right? And now all of a sudden, energy was not conserved at all in that system, Einstein. That 10 energy input went in and created a million billion energies, right? Because over time now, we've used this theory to make the entire human race more intelligent and to produce tools and technologies and theories.
You have to tell that the energy metric here is not...
It's not pure physical energy.
Yeah, it's different.
It's a universal energy.
From Emergent's point of view, it's like sum of the part has a better cost value than the sum of individual costs.
Yes, but you have to look at the interchange between and it's actually the same fundamental substance. There's one substance and it's this flow from the physical world to the mental world and back, right? So any agent, any cognitive system does this. It takes energy in, inputs it from the world, right? You eat something, and then you do stuff with that energy. You live and you survive and thrive, right? That's the fundamental cycle of the universe, right? You survive and thrive. How? Through sense making, right? Through sense making. This is the fundamental directive of the universe, right? And this is the fundamental strategy of the universe, right? Just like we were breaking things out earlier. Strategy. What's the motivation of the universe? Tension. Why tension? Well, it's interesting. That's what Einstein came up with that he didn't realize he came up with, that we realized he came up with, but I didn't understand what it meant initially. But that's the stupid c squared. Einstein, what the fuck were you thinking with c squared? It doesn't make any sense to square the speed limit of light. It makes no sense to me whatsoever. So I started thinking about it a little bit more. So I think about what Einstein might have meant by squaring the speed limit of light. What the hell? What the hell does that mean? That's so stupid. So stupid. But if you got a piece of light here is moving at the speed of light, right? What does it mean to square this speed limit, which is not even its actual speed? It's like the limit.
They don't use that all the time though.
But who cares? They do use it in this equation.
No, well, they take E equals MC squared and they replace C with like the actual relative speed.
Who cares what they do? They did it wrong. I don't care. So basically now what we can do is we can take light, right, and consider its waveform. And they probably did something clever and right like they were supposed to, right? But they should have also thought about this. And then we consider squaring it, right? So we have two waveforms. And they're pretty close. But as you said, like, it's the relative speed of light. The speed of light actually is never actually the speed limit of light. There's always some slight tension when you superimpose these two lines, right? So that tension, when you superimpose those lines, get rid of the gestural push in the Plato interface there. So that tension now looks like this. And we have two things here mapped, right? And now we can do the second version. It has just small deviation from it. Whatever, it's almost the same because it's basically close to the speed limit. But there's an interference pattern, right? And when that interference pattern is resolved, there's actually a third thing, a third pattern that emerges. So it's just like I don't even know, it's like some difference pattern between the two. So now we have 1 thing, 2 things, and 3 things, right? This is kind of like a positive, this is kind of like a negative, and this is kind of like a positive negative, right? The sum of the two, the emergent 1. The emergent 1. That's the sum of 0 plus 0. Oh, yeah, that's what it is, isn't it? Yash might understand what I mean. Do you understand what I mean, Yash?
Yeah, symbolically.
Yeah, symbolically. Because you added zeros on all the numbers, and you did that. You did it so that you would do that.
Yeah, that was my proof for like how can each number stand on its own.
Exactly, and I took that thing which you did. Yeah. Oh, how can it stand on its own? That's a flower bed. That's a foundation. 2 foundations plus a foundation equals solid. All right, and then
that's what the zero vector does.
That's what the zero does. They're both foundations that allow the number system to survive. You said that's what Yash told me, right? And then I went ahead and said, okay, take that foundation, add it with another foundation, and you get the thing that's the universe, right? And then we have 3 fundamental components. We have 1 c squared again, like Einstein said, the 2 fundamental sense-making curves right here, boom, boom. And then we have the emergent third. The emergent third thing, right? And unless we're looking at the interchange between the mind and the world, then you don't see that third thing. You miss it. Einstein missed it. You missed that shit. It was all right here. C squared. Didn't make any sense to me. No sense whatsoever. That was it, dude. Oh, and so how do we fix it? It's so simple. Okay, this is where I tell Einstein that even though I told him he was wrong, he would be very happy with the equation that resulted from it, dude. Because look at what, it's so simple. E equals mc squared, right? Square it! Square it! Square the whole thing. Because then you have 2 of these motherfuckers. You have 2. This is 1 E equals mc squared. This is another E equals mc squared. And you just have to continually keep them balanced in this dynamic way to understand all this shit. Automatically. And once you consider that and balance those equations with 3 equations rather than 1, then you'll do it. And then what's squaring it, right? So you have 2 equations, you put them together, and you have a third, right? That's why 1 simple squaring procedure is enough to give you 3 elements, right? That interact, because these 2 interact back and forth to give you that one, right? And so you just need 2, and it gives you the third, and then you have 3 things, and they interact here in tandem in order to change it. And that's the engine of life. That's why life pumps. This is this process. It's a little train. This is a spike train. It's like Yasha's spike train.
Yeah, spike train is like how much depth each node has to go in to compute that, like solve that problem.
Exactly, which is infinite. It's infinite potential.
Yeah, I mean you can infinitely recurse, but then it turns out to be a halting problem, which can never be solved.
It's impossible to solve, and we admit that it's impossible to solve. And who cares? We'll do so much cool stuff without solving that problem once we realize
do you have this in the presentation?
No, this is the first version of it. That's why I wanted to record it, and I need it now. I
send it
loaded
to you
up from the phone.
This reminds me of the double slit experiment.
Exactly, that's what it is.
Cancel out.
What,
Yeah.
Young's double slit?
Yeah.
It's the same
It's
thing.
That was Goldberg.
Oh, it's Birmingham Young or something. Or
Maybe it was, yeah, maybe I'm thinking something like that.
I have no idea.
And there's like
I
different
just saw
models too. Like Young's double slit is just one, and then there's like other experiments to confirm like the wave and particle nature of light.
Yeah.
Yeah. The wave particle duality is interesting. Oh, we still haven't told you about this one yet. The tree of what's it called? The tree of creative souls.